So this lesson that I'm now recording, you can see up here at the top that it's being recorded. You see the numbers scrolling. This first lesson is just introducing the trigonometric ratios. So like I said before, we're going to use those ratios to find side lengths and angles in triangles, but we first have to figure out how to label a triangle. So this says, label the sides of each triangle relative to the given angle. The three sides of the triangle are hypotenuse, opposite, and adjacent. Hypotenuse you already know, right? So when I point to the hypotenuse, I want you to say, that's the one. So is it this one? No? This one? Yes, that's the hypotenuse. You can tell that that's the hypotenuse because it's the longest side, and it's the one that's opposite the right angle. So right angle's over here. Oops. Oh my goodness. Let's get that out of there. Right angle's over here. Hypotenuse is across from it, opposite the right angle. So on this one, is this the hypotenuse over here?
No.
No? This?
No.
So it must be this? That's the hypotenuse. You can tell because here's the right angle and directly across from it's the hypotenuse. And like I said, it's also always the longest side length, but sometimes it's hard to tell just looking at a diagram which one's the longest. But if you find the right angle and go straight across from it, you'll know that that's the hypotenuse. The other two, the opposite and the adjacent, switch depending on what angle you're looking at. So for this one, this is the angle that we're going to reference. It has a little symbol in there that's a theta, a Greek letter. Looks like a circle with a squiggly line through it, and it just represents an unknown angle. Like when it's an unknown side length, we often call it X or A or B or something. When it's an angle, we usually use a Greek letter. I don't know why, it's just kind of convention, that's what we do. So when you see that little circle with a squiggly line through it, that's just an angle. So this is how you decide which is the opposite and which is the adjacent. You look at the angle that you're talking about, which is this one, and go directly across from it. That's the opposite.
So the angle that you're looking for.
We're not really looking for anything in this one. We're not looking for a side length or an angle. We don't know any of them except for the right angle. So sometimes it can be the angle that you're looking for. Sometimes it can be the angle that you already know. And it'll depend on what type of question we're doing, which of those situations it is. But for now, it's just the angle that's marked as, here's the angle. So directly across from that angle is the opposite. That word adjacent means next to. So if you find that angle, that's the other side, the one that's right next to the angle. So we'll put adjacent in here. In the second one, we have the hypotenuse labeled. But then when we look at this one, that side there, what would you say that is? That's opposite, right? Because it's right there across from the angle. It's opposite the angle. And which leaves that one has to be adjacent. So the next thing we're going to talk about is the actual trig ratios. This question asks you to calculate the ratio of the opposite side to the adjacent side for each of these similar triangles. So when we look at the first little triangle there, what would you say is the opposite side of that? The 1, right? It's asking us for a ratio of opposite to adjacent. So for this one, we're going to go 1 is the opposite and 2 is the adjacent. It's equal to 1/2 for that triangle. What is the opposite in the second triangle? 2. And the adjacent? 2/4. What do you notice about those two numbers? They what? They're equal, actually, right? If you divide the numerator and denominator by 2, so you reduce that fraction, it's actually equal to 1/2. So those are equal. And what's the opposite side on the last one? And the adjacent then is 8, and what's that reduced to? 2/4 or 1/2. So they're all actually equal to 1/2, and this is the basis of trigonometry. It's that if you have triangles that are similar, the ratio of their sides is equal. Yes. This ratio of opposite over adjacent, that's the same for every similar triangle, is actually called the tangent ratio. And what that means is that the tangent of an angle is equal to the length of its opposite side divided by the length of its adjacent side. Here it asks you to calculate a different ratio. This one is the ratio of the opposite side to the hypotenuse. So opposite over hypotenuse. So if we look at the first triangle there, what's the length of the opposite side? 2. Yep, and the hypotenuse is 5. So that ratio for this one is equal to 2/5. If this is a similar triangle, what do you think the ratio will be? 4/10, which is equal to 2/5, right? This one's 4/10, reduces to 2/5. And this one is 8/20, which also reduces to 4/5. Sorry, not 4/5. 2/5. I was like, that doesn't work. 2/5. That ratio of the length of the opposite side to the length of the hypotenuse, which is also constant for all similar triangles, is called the sine ratio. So the sine of an angle is equal to the opposite side over the hypotenuse. Calculate the ratio of the adjacent side to the hypotenuse for each of these similar triangles. So adjacent over hypotenuse. In the first one, the adjacent is 3 and the hypotenuse is 4. In the second one, the adjacent is 6 and the hypotenuse is 8, and that's also equal to 3/4, same as the first one. The last one, adjacent is 12 over the hypotenuse 16. They're all equal to 3/4 because they're all the same ratio on similar triangles, and this ratio is called the cosine ratio. So cosine of an angle is equal to adjacent over hypotenuse. For these triangles, it's asking us to calculate each trig ratio. So we look at the first one. Here's the angle that we're talking about, and we're looking for the sine of that angle, the cosine of that angle, and the tangent of that angle. First thing we need to do is figure out which side is which. So what would you say this side is, the 3? Opposite, adjacent, or hypotenuse? Adjacent, good. And the 4? Opposite. So then the 5 is the hypotenuse. So then when it asks us to find the sine of that angle, sine is just opposite over hypotenuse. So we're going to take the opposite side, opposite over hypotenuse. The opposite side, which we said is 4, and the hypotenuse, which is 5. Which means that the sine of that angle is equal to 4/5. Cosine is adjacent over hypotenuse. So it's just equal to, anybody know? Three over 5. Because the adjacent side, we said, is the 3, the hypotenuse, which is 5. And then tangent is opposite over adjacent. So opposite is 4 and adjacent is 3, so the tangent is 4/3. So for the next one, sine is 21/29 because 21 is the opposite, 29 is the hypotenuse. If you can figure out which is the opposite, adjacent, and hypotenuse, then this part of it's easy. The cosine, we just need to remember, is adjacent over hypotenuse. So the adjacent side is 20 over the hypotenuse, which is 29. And then the last one, the tangent, is opposite over adjacent, 21/20. And that's that. One last thing that I want to show you though, today, is how we can use our calculators to calculate the sine of an angle that we know, or the cosine or the tangent of an angle that's known. So if you take out your calculator, we're going to try these. And everyone's calculator is going to work a little different. Well, not everyone. If you have a TI 83 or 84, something like this, first thing I want you to do is make sure that it's in the right mode. Everybody's going to do this, no matter what kind of calculator you have. You have to make sure it's in the right mode. So if it's this kind of a calculator, a TI 83 or a TI 84, press the mode button, and mine is not in the right mode. But now it is. Once your calculator's in the right mode, degree mode, all you're going to do is press sine 18 equals, or enter, and you should get an answer of 0.309.
How do I know if it's in degree mode?
If you got that answer, then it's in degree mode. When you do cosine 45, you should get 0.707. 70710678112. It's a big long number, but I'm just rounding it. 0.707. And the last one, tangent 70, 2.747.